All right, last one for this topic. Let's get excited. We can smell it. We can almost rub it. We can actually see the end because the end is right there. But we're almost there. Oh my God, yeah, oh my God. All right. So, yesterday? Wednesday. Yesterday. That seems so much longer ago. I just missed you all. Okay, so, yesterday we talked about, what did we talk about? We did talk about something.
Smoothing.
Smoothing, what type of smoothing?
Medium, 3 groups.
No, that was, actually no, we did do that, yeah. Yeah, so okay, we did do median smoothing. And after median smoothing, what did we do? Yes, seasoning. Oh, I like seasoning on my chicken. Don't know. Seasonalising. I can't even spell it. Thank you. Yes, we had oh my gosh, I'm struggling. And deseasonalising. Okay, so this is what we talked about yesterday. We talked about having data and it's affected by the season, so we've got a graph with lots of variation. We talked about deseasonalising the data so that we could graph it, get rid of a lot of that variation and see some other trends. Then we talked about, okay, if we've got some data that is already deseasonalised, how do we re-seasonalise it to take the seasons into account? So that's what we did yesterday. And yesterday I said that once we have deseasonalised data, we can analyse it. We didn't do any, or not much analysing yesterday, so that's what we're going to focus on today. So we've got some data, it's seasonalised, so we deseasonalise it, we analyse it, we're going to do some things to it, and then we re-seasonalise it to get our actual values. Does that make sense? It's pretty much the gist of it. Okay, so if a T series, a time series plot, looks like it may have a trend, then we can fit a trend line to the data.
Is that one word?
No, it just looks like it. Once we've fitted the trend line, we can make predictions about future trends, which is called forecasting. So when we are fitting a trend line, we are fitting a line that represents the general trend. And the type of line we're going to fit is one we've used a lot. We're going to fit a least squares regression line. Please tell me everyone knows what I'm talking about when I say least squares regression line. Good. All right. So, fit a trend line, we can forecast. And forecasting is pretty much like predicting. There's a few extra steps we have to do when we've got seasonalised data. Okay, so first of all, we're going to construct a time series plot for the data in the following table, which shows the number of government schools in Victoria over the period of 1981 to 1992. So to put these into our calculator, what are we first going to do instead of putting in the year? Yep, good. So this is going to become 1, 2, 3. All right, and that will be your list 1, and that will be your list 2. So put that into your calculator, and as usual, fit a least squares regression line to that data.
Is it X, Y, or scatter?
XY. So construct your time series plot on your XY plot and then fit a least squares regression line to it. Making sense? Yeah. So just construct a normal time series plot, your X line plot, and then put a regression line on it as usual. Yep. Yep. Yeah. And then, yeah. Yep.
Is it Y versus
Y equals AX plus B.
So we just write that, we just fill in the...
Yep.
Do we write that equation?
Yeah.
How many decimals?
Just go to one decimal.
Is B 2169, is that what it is?
Yes, that's what I got. Anyone else get that?
2092. What is it? 2169. Is it 12.5 or minus 12.5?
Yep, thank you. Sorry.
Why are we putting a negative?
Because it's a negative number. Do you want to come up with a negative number?
How do you get 5?
Your dad looks like your father. 219, 210, 2124, 2118. Yep. 2114. 2091. Yep. Yep. No. 2059. Oh, sorry, 2038. This one might be. Yep, and then you just need to redo your snap bar. Yeah.
Sorry, I'm just... How do you find the equation? What do you...
So put your, so just like normal, put your regression line in.
Yep.
Yep. Yep. You don't need a copy.
Oh, okay. Cool.
Anyone not get this? Okay, so next bit, write down and interpret the slope. So, make it explicit, slope equals negative 12.5. What does this mean? So a decrease
I don't think I put it back.
of 12.5
Make sure you get back. Yeah, I will.
schools each year.
So we don't have to do the one that's back. So if that's predicts every increase in the area of an increase by.
Look, that's probably a better answer. But if you just remember, that's just short, that'd be okay.
Oh, so you could back.
Yeah.
Can you please check say that?
Okay, because you've got your data, don't need this one. So what we can do is just go
Increase in the year.
regression, just go list one and list three. Yep, perfect.
Yep. I'm sorry.
That's okay. Okay, can I move down?
1 minute. It was decreased by 12.
12.5.
What would that be, like 12.5 what? Or just
12.5 schools. Yep.
Okay.
Wouldn't it be negative 12?
No, we've already said decrease, so we don't need to put the negative 12. All good? Okay, so then the last question for this bit is, how many government schools do we predict for Victoria in 2015 if the same decreasing trend continues? Give your answer correct to the nearest whole number. So to do this, we're going to use our equation that we have, so number of schools
Is it 2015 or is it 35?
Okay, so because we have numbered these as 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 our line, our equation is in relation to 1, 2, 3, 4, 5, 6, 7, 8, blah, blah. Alright, so if we put in 2015, we're calculating that as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, keep going all the way up to 2015. Does that make sense? As a number, not as a year. So to find out what year 2015 is, we need to calculate, so keep going until we get to 2015.
Is there a quicker way to do that? Or
Well, if this is 1981 and we're trying to get 2015, how can we work out how many? Yeah.
Would it just be 12, 13, 14, 15?
Sorry.
Would it just be 13?
14 and 15 until you get to 2015.
Oh, okay.
Yep.
But how would you find the number for the year?
So if you wanted to, how can we find the number? How can we find the number if we wanted to find out what year 2015 was, what number it was?
2015 minus 9.
Yeah, that's fine.
I just did 8 plus 59.
I just did
And then added on to 12. I don't know.
What did you do?
I did the difference between like 192. Like, I don't know how to explain it, but I just did 8 plus 15
192.
plus 12 because we're already at 12.
Oh, and you knew it was that many years to get to 2000, so
Yeah.
you counted on.
Kind of. But
Okay.
Quickly.
Yeah, I get ya. What did you say, Caitlin?
I just did 2015 minus 9.
Yeah, so that's probably the quickest way to do it. So we want to get to 2015, which we know is over here. We need to work out how many differences there is between here and here. So the quickest way to do it is probably go 2015 minus 1981, not 81, 1981.
Is it plus 1 as well? Because that gives us
Oh, you're right, it's 90.
Yeah, but it ends there. So how do you calculate the difference?
Well, what did you get?
like 8.4 if I do
The
2015 minus 1981. But then should I add 1 to make it 35?
Yes. All right, so our answer should, so our year is going to be what year number?
34.
It needs to be 35. So, all right, what have we done?
Was it because 81 is counted as a year?
81 should be, because we're, okay, this is our year 1, not our year 0. So we need to go back. So if we're doing this, we need to add a year on.
Why?
Because this is 1, not 0. When we start counting, what do we start counting from? 0.
So what is the...
If we've got 0 plus 1, we plus, we're
So you
at
start at 1980.
Start at 1980, yep.
So then it's 35.
So 1980 would be 0.
So it is 35.
It is 35. Does that make sense? What we just all spoke about, discussed? Yep. Okay, so we need to sub the number 35 into the year. And what did we get? What did we get?
1739.56.
Yep. And we're going to, it says to the nearest whole number, so we're going to round it up to 32. So at the moment, we haven't done anything with seasonalising or deseasonalising. We've just looked at some data. There's no real seasonalising in it because it's just year to year to year. There's a decreasing trend. And so we've just worked out how we can use a time series plot, fit a regression line to it, so making sure that we've changed our X values to just single digit numbers, calculated our regression line, and then how we can predict or forecast numbers using our regression line. So making sure, so this bit here, this 35, that is really important when we're using forecasting if we have substituted these in as 1, 2, 3, 4, 5, 6, 7, 8. Does that make sense? Yep, cool. Any questions? Okay, can I move on? Yeah, question?
How did you get like the takeaway of the years thing?
So we went to the first one,
Yeah.
which was 1981. We're starting at 1980 because we need to get to the 0, where we've called this number 1. Yep, so we're going 2015, take away 1980.
Oh, right, just because it's no 19.
Make sense?
Yeah.
Yeah. All right, can I move down? Okay, so now we're going to have a look at doing it with seasonality. So when we have seasonalised data, before we can fit a least squares regression line, to the data, we first need to deseasonalise. Alright, so the deseasonalised quarterly sales data for Mickey's shop are shown below. And I think we looked at some of Mickey's data yesterday, but this is just different data. So, we were talking about summer, autumn, winter, spring, summer, autumn, autumn starts with an A, winter, spring, summer, autumn, winter, spring. So this is sort of a continuation from yesterday. Making sense?
Mm-hmm.
Girls who weren't here when we did this, if you're confused, I'll catch you up. Alright, so first of all, we need to fit a trend line and interpret the slope. So again, we need to put these into our calculator and we need to get a regression line. So because we can't use summer, autumn, winter, spring in our calculator, they've already transformed it to 1, 2, 3, 4, 5, 6, 7, 8. So that we can put it into our calculator. So that's list 1, list 2.
Would you say for every increase in season or quarter or what?
Quarter? Yeah, by quarter.
How
You can also write. Yep, they're the same thing. Over the 3 years, sales have increased by 32.1 sales per quarter. It's really important that you say per quarter because that's what we're going up by. If you don't put in per quarter, you're saying this is how much they increase per year, which they don't increase per quarter.
Would you say by season or?
You could, but because it's got quarter, I would use the language of that. All right, and the last bit, yes, the last bit for the whole topic. Get excited. Whew, yeah. All right. All right, when forecasting with seasonalized data, 2 steps. First, we needed to find the predicted value for the deseasonalized data. Then we need to re-seasonalize the data using the seasonal index. So, what sales do we predict for Mickey's shop in the winter of year 4? The seasonal index for winter in year 4 is 1.3. So, first of all, we need to work out what number is winter in year 4. Because we've got summer, autumn, winter, spring. That's year 1, year 2, year 3, summer, autumn, winter, 13, 14, 15. So we need to use the number 15 to predict because that's what order, or that's what place winter year 4 is. So using our, either one of these formulas, our equations. So sales equals 8.38, oh not 8.3, 838. 2.1 by 15. Put that into your calculator.
Is that a top plus?
There.
Yeah.
Yep. And what do we get?
1, 3,
1319.5? Yep. Did you put 32.1?
That's why
19.5? Alright, and the very, very last step is we need to re-seasonalize this data for the seasonal index. So what this means is we've got our graph with our deseasonalized data, so it's looking a little bit flatter. We've got a trend line through it. We've predicted the data, and it's saying, okay, for our deseasonalized data, we're predicting it to be about here. We're predicting it to be 1,319.5.
Do you have to do a graph?
No, you don't. I'm just showing you what it means. All right? Well, and that wasn't very to scale, but you know what I'm talking about. Okay, so now if we put the seasonal variation back in, so we've got it a little bit more like this. What should it be in winter? So to find that out, we need to multiply this number by the seasonal index. So we've got re-seasonalized let's say value. Value equals 1319.5 times 1.30. And it equals 1715.35. Now, if we're talking sales, we probably can't really sell point of something. So we round that off to 1,715.
So it was 1319.5 the predicted value for this deseasonalised.
Yes, so that was deseasonalised.
So if you were to get, like, if you were calculating number of people, would you round it up? So if you're like 1715.35 people, is that 1716 people?
Usually, yes.
Okay. So is it only with people that you round up?
Yes.
Okay.
When you're, you know how you change the quarters at 1, 2, 3, 4, 5, 6, 7,
Yep.
Can you start at like, say like 3 or is it always 1?
Usually just start at 1, yeah. Alright, and so that would be the actual value when we take the seasons into account. Is there any questions? We're done. Yeah! Oh.
Yeah!
I thought you'd be more